We want to start the meeting pretty soon. So if there's anybody out in the hall, now's the time to come in. Well, I'll stand up and get us started. We're delighted that all of you could come tonight. It's a great opportunity to hear something about climate change. But before we do that, I want to point out that we asked and have received 36 different organizations in Billings to help sponsor this event tonight. And also what we're now calling Billings Climate Week. It's not just this occasion, although this is the main event, but there are a number of other things as well, and I want to go through that also. But before I do, I want to read to you who are some of these 36 organizations. I'm really impressed. I'm going through it alphabetically. Agri-Organic, American Association of University Women, Beyond Plastics, Big Sky 55 Plus, Billings Association of Humanists, Billings Friends Meeting, Billings Unitarian Universalist Fellowship, Citizens Climate Lobby, the Climate Project presenter is Chuck Tooley. He was presenting this same thing some 10 years ago for Al Gore. And as you know, Al Gore was very concerned about climate change. And going on, the Columbus Congregational Church is also sponsoring him tomorrow. And the Environmental Studies Program of Montana State University Billings, Susan Gilberts. And by the way, she's here, and she is the one that set us up with this meeting today in Petro Hall. So we really appreciate that. Families for a Livable Climate, First Congregational UCC, Forward Montana, Interfaith Power and Light Montana, Kirk's Grocery, League of Women Voters, Mayflower Congregational Church, Montana Audubon Society, Montana Environmental Information Center. Continuing, Montana Conservation Voters, Montana Health Professionals for a Healthy Climate, the Northern Hotel, Northern Plains Resource Council, Our Children's Trust, Our Montana, the Pub Station, Riverstone Health, St. Andrew's Presbyterian Church, Sierra Club, Sustainable Billings, Sweetwater Rising, United Campus Ministries, here of MSUB, Wild Montana Eastern Chapter, Yellowstone Valley Audubon Society, Yellowstone Valley Citizens Council, Zonta Club of Billings. So I'm really impressed. 36 different organizations. And I think that indicates that there's a lot of interest in this subject. It also indicates that we have a really good speaker. And to introduce that speaker, I'm going to turn the mic over to Chuck Tooley. Oh, I should say, Chuck, as you know, is a former mayor. Been mayor for how many? Many years. Many years. And he is very active in a whole bunch of things since.
Thank you, Tom. So I have some notes, and Susan Gilberts gave me this. Did everybody get one of these envelopes from MSU, Billings Foundation, and alumni? If you didn't, they're out on the front table. So Anyway, I'm very pleased to be able to introduce Dr. Steve Running, who is an emeritus Regents Professor of Ecology at the University of Montana. In addition to teaching and research work, Dr. Running has shared his talents far beyond Montana. He was appointed to the Intergovernmental Panel on Climate Change in 2004. And since then, he's been a member of the Earth Science Committee of the National Aeronautics and Space Administration, chairman of the Earth Science and Applications Committee of the National Academy of Science. The Nobel Peace Prize for 2007 was awarded to the Intergovernmental Panel on Climate Change. And, yes, as well as, this was a shared Nobel Prize, as well as to former U.S. Vice President Al Gore for their efforts to build up and disseminate greater knowledge about man-made climate change and to lay the foundations for the measures that are needed to counteract such change. I met Dr. Running in Missoula when I was there speaking for the Climate Project. It was in 2006, and Matt Leo of Montperg took me to Dr. Running's office on campus where the three of us had a great visit about climate change and public policy. 5 years later, I was serving as director of the Urban Institute for Montana State University in Billings, and we hosted a full day of events about climate change that included Norwegian ambassador to the U.S. Weger Stroman, Dr. Steve Running, Dr. Knut Alfsen, a Norwegian scientist, and Douglas Holtz-Eakin from the American Action Forum. We filled a downtown meeting room with business leaders that day so they could listen to the truth about climate change. By that time, Dr. Running was sharing a Nobel Peace Prize for his work with the Intergovernmental Panel for Climate Change. I worked at a much lower level, traveling the country, speaking, but we both have been soldiers in the fight against climate change, and I count you, Steve, as a brother in arms. Ladies and gentlemen, please help me give a warm Billings welcome to Dr. Nobel laureate, Dr. Steve Running.
This is a great auditorium for speaking. Over the years, I've been in some places not so great, and this is really an excellent setup here. I think I traced back, I gave my first public talk on climate about 2000, so about 23 years ago. And so I'll just touch a bit on the history, very few minutes about it before we get to where we're at now. And there's probably one principle that I've found that's most valuable to get everybody in the right frame of mind to think about this issue, and it's this one. We like to call Montana big sky country, but to a climate scientist, the atmosphere is the smallest component of the climate system. And so the ocean is by far the largest, and as we'll see in a bit, the land surface is a bit bigger. But the point is, once you realize that the atmosphere is small, then it makes sense how we can fill it up with pollution because it's such a small reservoir. And so this initiating concept I've found just gets everybody on the right wavelength, that the atmosphere is really small, and that's why it's been really quite easy to fill it with the sort of carbon pollution that we now are doing. The real history of this starts way back in the 1850s to finally in 1890, when a Swedish chemist named Svante Arrhenius, that by then they'd understood that the carbon dioxide molecule is this odd little molecule that has this property that sunlight can come through an atmosphere of CO2, but the thermal radiation, the thermal wavelengths coming back out get absorbed by that molecule. And so that's what we call the greenhouse effect. We all know it every bit. Every time you park your car in the sun and come out there an hour later, all that sun that went through the glass of that window and the thermal couldn't go back out, you're seeing the greenhouse effect right there. So the basic principles of what all of this is about have been known for well over 100 years. And so that's where this topic started, but then it was really just academic curiosity. Charles David Keeling, riding up the chairlift with me in Snowbowl in Montana years ago, started the measurement of atmospheric CO2 at Mauna Loa, and it's now known as the Keeling curve. It's almost certainly the most famous geophysical measurement in the whole world. And it is the foundation of where we started to realize that we were filling the atmosphere up with carbon pollution. Before then, we just had no idea. We just had no idea that there was anything wrong. And so he started that in 1958. He told me later that by 1965, they fully knew, they understood what was going on. So this is a topic that in the scientific arena, we've been very clear about fossil fuel emissions rising, the concentration of CO2 in the atmosphere, and the resulting increase in temperature. We've now known for 50, 60, 70 years. This is not a new discovery at this point. Now, one of the things you can't quite see from a distance is it oscillates every year. And that's actually the photosynthesis of the entire northern hemisphere, drawing down the CO2 in the summertime growing season, and then releasing a lot of it back to decomposition in the winter. So this is the first time we ever measured the entire planetary photosynthesis. And being a forest ecologist by training, when I realized that, I thought that was really quite cool. And so that was the start of the science of this, and well before the politics of it. We now clearly have the record. This is a combination of the land and ocean temperatures that are the trend that particularly is resulted in the last about 40 years of progressive heating. This is certainly not news anymore to anybody that pays any attention to this. And I would note, these are measurements. These are not computer models. The part that gets, I think, is not so obvious to us until it's presented. I know when I first saw this material, I was pretty surprised, and I'm an earth scientist. The ocean has absorbed about 95% of this additional heat that's being trapped by the greenhouse effect over the last 50 years. And so the land a little bit, and this is where you see that the atmosphere is only a couple percent of the heating. So even though we're measuring atmospheric temperature, the actual heat content of the climate system is really being driven by the ocean warming. That's an awful lot of the reason why it's hard for us to predict what will happen to that energy. Where's it going to come back out? Where, when, how is what climate science now tries to figure out, because it's all heating the ocean waters to I love this number, 228 sextillion joules per year, a number that not any of us can relate to at all. But it certainly just gives us the impression of this, of the just overwhelming amount of additional energy that is being trapped by the greenhouse effect of the atmosphere now. Now, I'm not going to spend very much time on the climate impacts because there's a lot of newer things to talk about, but I want to touch on a couple. And sea level rise is one of them. We know the sea level is rising about 3.4 millimeters a year. We know that from laser altimetry from satellites turns out to be the most accurate measure of sea level worldwide. And we're already having situations in Miami where at high tides, the streets are flooding like you see in the picture in back. Most global scientists now recognize that probably the single biggest impact to humanity of climate change is going to be the rising sea level. Because when you look at how many of the major cities of the world are all around the coastlines of the world, and we expect sea level to be probably a meter higher by the end of this century. And you think of that meter higher and then a high tide on top of it, and maybe a hurricane surge on top of that, and that's when all hell's going to break loose. And so this is very accurately measured worldwide for those reasons, and we know it's coming. It's already well underway. Now for us, maybe the most obvious issue is the melt out of the glaciers. And of course, we recognize Glacier National Park. They've done these very interesting to look at historical photo pairs where they find an old picture and then go and replicate that picture from the exact location. And it just illustrates, I mean, I really don't even need to say anything. I just point at the picture. The inset graph there just illustrates that glaciers worldwide, 95% of the glaciers on Earth are retreating, and with modern satellites we can measure all of them actually quite accurately. So our glaciers are on the way to melting out worldwide. The other topic that when we did our IPCC report in 2006, we weren't quite sure about yet, so we couldn't say anything, but now we are sure, and we being the climate science community. Our major storms increasing, and what's now clear in the statistics is for our Gulf Coast hurricanes, the number of hurricanes is not going up, but the hurricanes that do form tend to get bigger and stronger. And this illustrates that the greatest increase has been in Category 5 hurricanes, like we hear about in the news. NOAA has now defined a Category 6, and they're figuring within a decade or so we'll have the first Category 6 hurricane. Luckily, that isn't our end of the country, but it's an illustration of what we imagine is going to develop in terms of extreme events. We're now documenting stronger tornadoes also. And so this is a manifestation of all that 228 sextillion joules of energy popping out into the system as these extreme events are accelerating. That's my last kind of global impact slide, because I want to quickly start getting closer to home here. This comes from the Montana Climate Assessment that was published in 2017. If you have never seen it, you can download it for free and online, and it really gives you a look at in detail of where the Montana climate's going. And again, this is not computer models. This is the actual weather records from our weather stations compiled. I'm just giving a few slides for a talk like this, but there's a lot more in there that if you're interested, I really recommend. What this shows is the temperature trend in degrees Fahrenheit per decade of increase over this 65-year period. And the thing I want you to notice is it's pretty consistent around the whole state, that the whole state is going up something like 0.4 of a degree per decade. That means that something like 2 to 2.5 degrees warmer for the average temperature of Montana compared to 60, 70 years ago. And the consistency across the state, I want you to notice, because look at the precip is way different. You'll notice most of the state, there's no trend in precipitation. It hasn't gone up, it hasn't gone down. As we know, there's lots and lots of year-to-year variability. And within that variability, there's a bit of a trend on the west side for slightly declining rain and snowfall, a little trend in the southeast of increasing precipitation, but overall, really not much of a trend. Now, this just gives you a look at the variability of both the precipitation and the temperature, and lots of variability. When we look at climate, we really want to look at least 50 years and even 60, 70, 100 years of record. You don't learn anything about climate looking at 2 or 3 years. No matter how hot it is today or how hard it rains tonight, that doesn't tell me a thing about climate. That tells you a lot about weather, but to see climate trends are the kind of time series we're looking at here. Okay, so that's a quick, you get one slide each of lots of topics tonight, because that's, I want to get to a lot of different things, and that's the way I do it. The future. First, it's useful for us all to understand how the future projections are made. And these are done by GCMs, as they're known in the crowd, global climate models, or sometimes formally called general circulation models. And what those are is basically you define across the entire Earth's surface a three-dimensional set of cells that are something like 20 or 30 cells deep, going down into the deep ocean to the land surface, and 10 or 20 layers up into the atmosphere vertically, and then horizontally you have cells like a grid on a map around the whole world, and you're calculating the energy and mass flow in and out in every one of those cells at something like 10-minute intervals for 200 years. And this takes the biggest computers on Earth. This and the Human Genome Project are two of the most challenging computer exercises humanity has ever done. And most countries have one team that is the national global modeling team, and this is hundreds of scientists and computer technicians to run their global model. In the US, we're a bit bigger, so we have, I think, 4 international caliber climate models here, and most countries maybe have 1. What we then do to look at Montana is we chisel out the cells for our part of the world, and then we downscale them with the local topography so that there's a little bit more detail of the topography. But we don't add any additional calculations. It's still the global level computation. And the reason I'm pointing that out is you can't expect any real detailed projection. These are only producing general trends expected for the future. So this, for example, for the Pacific Northwest, you see a summertime look at temperature, and across the entire Northwest, kind of like our historical trend shows, is a pretty consistent warming pattern across the whole Northwest. And the precipitation in these model runs is what's a little bit unnerving, and I watch this a lot. They actually expect, or I should use the word project, that our wintertime precipitation might go up a little bit here, but our summertime rainfall, they project, is going to go down. And so that just means our dry ecosystem here is going to get drier. And that's what we have to be ready to deal with in Montana in the future. One of the things that these GCMs do not do is compute extreme events. They're computing basically the averages of the dynamics of the system. They don't in any reasonable way calculate the spread, the distribution, the extremes. And the extreme that I'm pointing out here of 2 years ago, literally, 2 years ago, right about now, were these absolute mind-blowing temperatures that hit the Pacific Northwest. I grew up in Seattle, and we thought a day in the low 80s was pretty amazing. So we never imagined 108 could occur. Nobody imagined it could be 116 ever in Portland. This is something that stumped the best climate scientists. They're still trying to figure out what happened, because this is a look at the kind of occasional extremes that we're going to have to be ready for. If it could happen here, it could happen again. And in ways and at times that we've got to be better at least forecasting a few days ahead and getting ready for, because these are conditions that we didn't think were possible. They literally were outside the bounds of our climate modeling. Uh-oh, come on. No. Sometimes the computer goes to sleep if I talk for too long. Yeah, all right. No, I don't want to customize the status bar right now. I'm kind of busy. Geez. All right, we're going to force this. Come on. What is the problem? Oh, now it asked me if I want to resume the slideshow. Duh, there's a lot of people waiting. I'm getting a little confused why this won't launch. It still wants to resume the slideshow. Boy, it is stuck, and I've tried everything that, no, why is it even asking that? Pretty weird.
There you go.
There we go. I could go ad lib for the rest of the hour, and maybe that'd be better, I don't know. So one of the things NOAA, our weather service, started tracking a few years ago are what they call billion-dollar disaster events, weather-related disasters. And you see that graph starts over there in 1980. And this, if you can see on top, is a combination of tornadoes and flooding and wildfire and severe storms and ice storms, and this is all the big disasters. And the point to make here is that it's going up, that this is what we have to be ready for and have to build resilience for, is that these kind of extreme events and disasters we have to just be more ready for than we are now. And it's interesting, you might have seen in the news in the last week, a couple of different states, the homeowners insurance companies have backed out of writing new policies. Imagine if they came here and said, you know what, your house is under such risk, we're not going to sell you homeowners insurance anymore. Wow. And luckily we're not in that kind of case here, but it just gives you a look of a possible future where large parts of the country might be in this kind of situation. I'm a little afraid to touch this now. Let's hope we get the next slide. Oh, good. A nice, so now there's another whole topic. You're getting your money's worth tonight. I'm giving like 5 talks in one. So now we're going to not talk about climate for a while. We're going to talk about the carbon cycle. Okay. This is a compilation of global emissions by all countries in the world. And you see starting in 1990, and you'll notice the only 3 times it's ever gone down has been when there's major economic disruption. And otherwise, it just, the next year starts right back up. And here, after COVID, has been a perfect example. It started right back up. And so this is the emissions worldwide. And again, based on measurements. Let's look at where it's coming from. The highest emissions in the world overall are from coal. And that's why, to me, the most important thing for us to do is to quit burning coal and quit selling it to anybody else to burn. Because if China burns it, I like to tell people the barges that take the coal to China, the CO2 comes back faster than the barge does. And so it beats it back home. And so anywhere Montana coal is burned is every bit as much of a problem as if we burned it right outside here. And so this is absolutely priority number 1 we see worldwide, is to end coal burning, and particularly for electric power. Part of also the reason that we target that is it's something where we have alternatives. We're going to talk a little later about things that we don't have good alternatives for that are going to be way harder, but this is something where we have choices if we just go do it. You see oil. Some people think we might have hit peak oil. We will know in a couple years, and so that oil curve, maybe it's our fantasy that we think it might be leveling off. In a couple years, we'll find out. And then natural gas is still going up. A lot of people don't know that generating cement is quite a CO2 emission. And so that's something that there's a lot of interesting new chemistry on trying to do cement without the normal processing that they do now. Since 2000, the emissions have just gone to the moon from China. And you'll notice that our overall emissions in the U.S. have actually gone down in the last 20 years. And so we're at least getting started. And so I like to think we should at least be a little bit proud that we're turning the corner. And the same with Europe. The same certainly with Japan. Russia has its own way of dropping its emissions. And so this really, China and actually I could add in India and Southeast Asia more generally, but really China is the biggest one. They are still building new coal plants. I read it every few weeks. Yeah, they're building, and a couple more have now come online. And so to be building new structures that tend to have about a 50-year lifetime is the last thing we need, and yet that's what's going on. Now, in case we get too smug about this, that it's all their fault, we have to acknowledge this. On a per capita basis, we're still the largest emitter, and certainly the largest historical carbon emitter in the world. And we have some friends that they don't show on this graph, but on a per capita basis, Australia's right up there with us, Canada's right up there with us, Saudi Arabia's up there with us. And so the good news is we do see it pointing downwards, so we're slowly driving that down, but we have to recognize that our lifestyle is still more profligate in carbon emissions than about anywhere else on Earth. And so I like this diagram because it kind of puts all the pieces of the carbon budget onto one slide. And so on top is the fossil fuel emissions, what we've just talked about. About 89% of the emissions notice these are anthropogenic CO2 emissions. 89% are the fossil fuel burning. Actually, there's 11% of CO2 emissions that come from agricultural burning, from wildfires, from deforestation for palm oil plantations, things like that. That is not a zero number. So we have some opportunity, along with reducing fossil fuel emissions, to do better land management. And if we do, that's a measurable part of our equation here. Okay, and then on the other side, where's all this CO2 go? Well, we're pretty confident about 26% of it goes into the ocean. It's literally just dissolved into the ocean water. 29% is taken up by the land biosphere, all our trees and grasslands and natural and agricultural land. And then the final residual, you might say, is the Keeling curve. It's what remains in the atmosphere and has those emissions going up as we see in the Keeling curve. So that is literally the inputs and outputs of carbon in the components of the climate system at the global scale. One other topic that you might hear, and so this is a little bit of a ringer, but I decided I really wanted to talk you through it because we're in a semi-arid climate here in eastern Montana. And you'll if you read any kind of climate summaries, they often will say something to the effect of, well, wet areas are getting wetter and dry areas are getting drier. And at first sound, you say, well, how can both of those be true? That doesn't add up. What's going on? And I even admitted it took me a bit of really thinking hard through the pieces to finally make it really clear in my mind. And it's all about the saturation vapor pressure curve, which you should all know about. And I'm not going to tell you today, but look it up. When I have a longer than an hour, I actually show the curve and I talk people through it. But all it represents is as air warms up, it can hold more water vapor. So if you go to Florida and you get off the plane and it just hits you like a ton of bricks as you take the first breath getting off the plane, it's because that air is hot and full of water vapor. And so when we see temperatures going up, like we see in the Montana trend, a couple of degrees warmer air temperature, that air can hold more water vapor. Well, it can only hold more water vapor if there's water to evaporate in there. So over the oceans, that warmer air absorbs a lot more water vapor and generates these atmospheric rivers that we read about hitting California. But if that air is over a dry surface, there's no water to evaporate into it, and so the dry gets drier. And so once you think it through, it totally makes sense that warmer air will either pick up water vapor and have more clouds and more rain when you're coming off the ocean. But when you're coming off a dry landscape like ours in the midsummer, that hot air just doesn't have any more water to take up from the surface. And so as we call it, the vapor pressure deficit, or you might want to say the humidity gets lower. And so that's how the dry gets drier. So it's a useful thing to think through because it's kind of a summary of where we see on a nationwide basis kind of this separation of trends at different parts of the country. Oops, oh no, don't start this again. You know what I think it's doing? Oh man, this is lecturing me to not talk too long. Because geez, give me a break, come on. Because I think the system goes to sleep on me. And I'm going in, okay. What, and every trick I have is not waking it back up. It's not even going back into sorter mode. What did you do before? I'm going to watch carefully.
I just hit the escape button
Oh, okay.
but that didn't do it, so.
Boy, this is my comeuppance for trying to give a complete explanation. Well, at least now we're really in trouble.
Hold on. That might be part of the issue.
Oh, is it hopping to a different slideshow?
That's why.
Want to change your presentation?
There you go.
Okay, let's see if I can come through and get to the end of this. The reason that I went to the effort to talk through that wet and dry part is I'm really convinced for Montana the pure temperature increase is not going to be our big issue. It's going to be this increasing aridity, this changing of our system water balance, where it's just going to get drier with time. And then the results of that dryness, and especially triggering disturbances. And so, for example, on a dry year, this was a picture from March 4th at 7,000 feet on a north-facing slope. When we have a dry year, we can start the summer with almost no snowpack. Certainly this year, we've done way better, but we know darn well there's going to be years like this. Particularly for our aquatic systems, we did this study a number of years back. I didn't want to look at annual river flow. I wanted to look at the pinch point in August when it's the lowest flow of the whole summer. And this is what we found across all these rivers. The August low flow is getting lower and lower overall. And if you're a fisherman, you know that, I mean, Fish and Game sometimes has to close down fishing on these rivers because the water's flow is too low and the water's too warm. So this is very real already. So I see this, in effect, tug-of-war for our surface water supplies. The aquatic systems and our aquatic recreation, we want the water in the river. The farmers want water to grow crops. The energy industry uses water in the power plants. I just found this out a couple of days ago. If the Colstrip 3 and 4 power plants are closed, 50,000 acre feet per year of water will return to the Yellowstone River. That's the water that those plants use for cooling. That's not incidental. And I never see that talked about when they talk about closing Colstrip. Now, if we want to learn about what happens when a river runs out of water, I just watch the Colorado Basin now. The hydrologists have been telling them this is coming for 20 years, and they couldn't quite get around to deciding what to do, and now they've hit the wall. If you can see that boat ramp there at Page, that thing's it's hard to show, but it's a half-mile long, and it's dropped off the bottom of the half-mile boat ramp. And they're getting a short reprieve this year. They have a heck of a snowpack, but we are certain Lake Powell and Lake Mead will never fill ever again. This epic year might add 30 or 40 feet to those reservoirs. Well, they're a couple hundred feet down. And so it would take a decade of winters like we've had to fill them. I always like this slide of a wildfire from the space station. It's just a different view than you ever get. This, to me, is our Achilles heel. This is like our sea level rise, is wildfires. And all you have to do is read the 1910 history of what could happen and realize it's even hotter and drier now than it was in 1910. It's the wind holocaust that drove that fire, and it could happen again. And so this is the one thing that I worry about for Montana most, is whether we could have our extreme event of a fire that would just burn millions of acres in a couple of days. Oh yeah, no, don't start this again. There are so many studies that have studied, that are studying these wildfire trends. I can't even list them all. This just gives you a look. I think this big slide here shows it's getting hotter and drier, and guess what? You get bigger fires. And so there's very clear understanding of these trends right now in the science community. And it's simply the snowpack melts earlier. The system dries out up to a higher elevation, and so you have a larger portion of the landscape that's vulnerable to ignition events for a longer period of time. And it's just kind of a probability thing of when you get those fires. Now, the big unknown, and what blew up 1910, was the wind. If we get one of these, it's kind of like the Santa Ana winds in California. If we get a windstorm like that when we have fires burning, then who knows where it'll stop. And that's the thing I really worry about. I think all of our cities need to have a buffer zone around the cities and towns of a good half mile or more where they really make an effort to keep fuels down, because that's about all we can do. That's about the only way we can get ready. Okay, so now we're done with climate, and we got to talk about some of the socioeconomic things going on. The good news is how spectacular the price drop has been for solar and wind turbine, but particularly, as you see, for solar energy, starting there only not that long ago, 2009, at $359, and now it's down to $40, $50, something like that. This is really, we didn't expect that it could go this low. And so this has just been great news. It's really a testament to advanced engineering and manufacturing efficiency. You see that the cost of coal hasn't changed much at all. And so now both wind and solar are cheaper by a good bit. For any new electric power generating, it's cheaper to be building wind or solar than it is to burn coal. Even to burn coal in existing plants, and not even building a new plant, just starting with existing plants. So coal now is fundamentally uneconomic. And yet Northwestern Energy was proud of buying the fraction of Colstrip 3 and 4 for $1. And they're so proud of what a great deal they got. And you go, come on. Remembering back to the biggest emission on Earth is coal. And coal, in fact, as I got ready to come here, I looked over to the railroad tracks, and sure enough, there was a coal train going by. And every day in Missoula, every single day in Missoula, as I come down to town on my bike or whatever, I almost every day there's a coal train going by. And they're all going to Asia, and not only China, but they're all going to Asia. And yet, to me, this is what we've got to stop first. One of the things that's kind of out of the power of us as individuals, but is absolutely underpinning our problem, is the fossil fuel industry, coal, oil, and gas, get so many subsidies that we don't actually know what the true cost of those commodities are. I'll bet if I had to guess that the real cost of a gallon of gas is probably about $10. If we truly and honestly priced every aspect of that without the subsidies that are built in, I think it'd be on that level. Now imagine if it was $10 a gallon, how different we would use it. This is a great one. So I'm trying to help out on this one. I only buy clothes from Costco, and I wear them for a decade. And my wife will kill me for stating that publicly. It's actually, this isn't a joke. This, CBS News is reasonably a reputable institution. And this, I guess there's this fast fashion, maybe somebody in this audience can explain this to me, that some influencer will go on and do what do they call them, a TikTok or something like that, and everybody sees it and wants to have that exact dress or shirt or something, and the fashion industry then builds them real quick and ships them over, and within a couple months they're all bought, and they wear them a few times, and then they're out of fashion and they throw them away. And that is how we end up with that statistic, that it is more carbon intensive than the airline industry. Yeah, so let's now talk about the airline industry and all our other transportation. And this is the kind of slide that even if you can't read the numbers, all you have to do is look at those yellow bars. And of course, jet air travel is the highest unit carbon emission. And the bad news, The bad news, and boy, I've put my millions of miles in the air, so I'm every bit as much at fault. We don't have any real clear new technology for jet air travel. They're making efficiency gains a few percent at a time, but I can't announce some big breakthrough in jet air travel. Passenger cars, we're going to talk about that in the next slide, and certainly bus travel is way less unit carbon in it. I mean, we know this. This is not, this is just putting numbers to what we already know. And of course, the winner of all is biking and walking. And that's actually my next slide. I will confess that I was a bike commuter my whole life. And so even before it was cool, I just liked riding my bike around. The generation of electric bikes now, these e-bikes, is just incredible. And so now I pasted in some of the wild designs from Europe mostly that are just nutty. But I mean, a basic e-bike is just a great way to get around. Certainly in a town like Missoula, I'm seeing families that maybe have one car and then some e-bikes, and they do a lot of taking the kids to school and going to the grocery with their e-bikes. And that is just a great way to go for people that can do it. Now, then there's cars. We have finally hit the proverbial tipping point on electric cars. And I've been waiting for that for 5-6 years, and it is now absolutely here. When the last Super Bowl, every single car ad was for an electric car, then I knew we'd done it. We've turned the corner. Now, that is not saying that the system is all ready to go and working well. I know the charging network is nowhere ready for this yet, but there's going to be growing pains, but we're on our way. Did you know the piston engine is only 15% efficient? That 85% of the energy content of the gasoline you put in is just blown off in heat. It's about time we retire that technology. It is just hideously inefficient. And they're coming. They're coming, and it's neat to be able to say that now. I couldn't even say that 2 years ago. And this is now the part that gets really interesting. You can impress your friends now. Tell them you're all into V2G and see what they say. I didn't know that a week ago, so I'm kind of showing off. But that's the lingo now, and it's actually a very serious and a very interesting concept that is absolutely already underway. And it's basically vehicle to grid. Remember when the first electric Ford pickup ads started coming out and they bragged about, oh, if the power goes out, just plug in your truck and you'll run their house? Did everybody see those ads? Well, that's an early illustration of V2G. And what it boils down to is once we have a few 100,000 electric cars in our garages here in Montana, all plugged into the grid, if we have a peaking power event where right now Northwest Energy goes on the market and pays moonbeam prices for immediate energy, instead, they'll just be able to tap all these cars. And because these peaking events only occur usually for a couple hours or maybe a couple days at a time. They don't go for weeks and weeks. But for those couple hours, they need power and they need it now. Well, imagine if every one of us, our car just chips in and sends it some juice. And this is absolutely doable right now. The technology is not perfected, but it's absolutely under the way. And your Ford pickup battery, your Lightning battery, is about 10 times bigger than a Tesla Firewall. So I don't know why you'd buy a Tesla Firewall. This really is the sort of idea that I've seen only a few of where I say, wow, this can make a big difference that'll benefit everybody. It'll stabilize the grid. It'll give the grid storage, which is what we're badly trying to figure out. And it's basically going to be all our electric cars plugged in. Another thing that I don't hear talked about very much, you know, all our hydroelectric dams are 60 and 70 years old. And I was up at Grand Coulee just about a month ago, and I was asking some of the people there, they can rewind the generators. They don't have to replace them. They just have to rewind the copper coils of the generators. They increase the power output by 30%. And so when you think of all the hydro dams we have, we don't need more hydro dams, but we probably have a lot of them that would benefit from an upgrade like that. Now, this is another kind of one of my favorite things that I'm starting to see thought of more. In our part of the world, in this time of year, shade itself is a valuable commodity. I look for shade the minute it goes over 70 degrees, I'm looking for shade. Well, when we're putting solar panels up, why not put them up in a way that provides useful shade also? Every parking lot in Arizona should have a solar canopy over the top of it, every one of them. This is an example of a train in Germany that the train track is covered by solar panels for multiple kilometers. The shade itself is a valuable entity on top of the electric power, and it certainly helps to make deploying solar panels more valuable. This gets even better. I love the one on the bottom, all the cows standing under the shade of the solar panels. And all they did was raise the panels up about 5 more feet so the cows could walk under them. Otherwise, they're regular old solar panels, but they've lifted them up to provide useful shade for the cattle. They've done studies that a lot of crops do better getting a bit of midday shade. They do better. That midday water stress is alleviated a bit, and so you actually get higher productivity from that crop than when it's open. And this has been university studies that are really formal studies. And it's not going to be true everywhere, but it's certainly going to be true in our part of the world, that that shade is a valuable thing to work with. And then there's nuclear power, and this is one, boy, is this a slippery topic. The New Deal, you look at the history of generation 1, 2, 3 of nuclear power, and we recognize all the nuclear facilities around the world now. Well, the newest ideas they call generation 4 are SMRs, small modular reactors, it's known as. And the idea for this is you build the entire reactor in a factory and seal it up, put it on a giant truck, and take it to the site, dig a hole, and put it in. And so nobody opens it up. It's a completely sealed facility. And when its fuel is spent, they dig it back up, take it back to another factory for recycling. An important part of this is each one of them doesn't have to get permitted again. Right now, every nuclear plant has to go through totally separate permitting, and it takes forever, and that's how the costs go to the moon. The idea with these is once we've got authorized this design, and actually one of them has already passed the Atomic Energy Commission, I can't remember exactly, but they've passed their design phase. Then they're just replicating them like building cars in a factory. And their big challenge is they've got to get their costs down by a huge amount. You saw the solar and wind trajectory of costs. And so they don't have to beat it. There's places on Earth where you're not going to have either wind or solar for long periods of time, like the far north. And so if they just get to within decent shouting distance of those kind of prices, then there's going to be a role for these in the future. And I can't endorse them yet until I see it, but I'm watching these very closely because, of course, they're basically carbon-free in their power generation. There's other topics rattling around that I want to just let you know about. The carbon capture and storage is one that there's claims that they can absorb CO2 from the atmosphere, compress it, and then squirt it down existing oil wells and locked into the rock formations. I'm not a very big fan of that. That costs so much to do. I'd rather use that same money in a lot of other ways. They call trees growing carbon capture and storage too. It's kind of funny when you're a forestry professor and they call the trees a carbon capture point. But that's my kind of carbon capture and storage, is let's grow more trees. And then there's green hydrogen. And this is a curious one. I initially thought there was no future for hydrogen because you have to compress it to really scary pressures like 5,000 psi. Remember, your car tires are 30 psi. 5,000, man. But it appears that it could have a real role for sopping up surplus power and to generate green hydrogen that then can be used in more industrial purposes. And so I'm starting to pay more attention to this. And I had one of our PSC commissioners tell me that up his direction by Great Falls, there's times when the grid is overloaded with electricity and they have to turn the wind turbines off. If there's anything that just makes you want to cry, is turning them off. Come on. And so this is the sort of thing that, if this can be perfected, would use that surplus right on the spot to generate hydrogen that then is going to have industrial uses. So I'm watching this more than I used to. All right. And then there's food. Our food system globally really needs a lot of work. The first and the easiest things is the labeling is absolutely ridiculous. People throw away so much food because it's supposedly past expiration date that is just wrong. And yet the government can't seem to get around to fixing this, even though this issue has been around for a long time. More generally, it's absolutely unbelievable. Study after study shows around a third of the food grown ends up not getting eaten. A third of it. Think of all the effort and time and fuel and everything these farmers did to grow all that, and a third of it ends up wasted. And so that, to me, is the kind of fixable thing that is just a good idea on general principles. Of course, the carbon footprint of different food is highly different. You see at the very left side there, of course, are the meats and beef, and this is something that the ranching community is very much on high alert of this issue, that their products is one of the highest carbon footprints of all these. I'm not going to endorse vegetarian or vegan eating. That is so much a personal choice, but we recognize that different foods have a lot of a different carbon footprint. The world population is stabilizing. We hit 8 billion, but when I was in college, they thought it was going to go to 12 or 14 billion, and now we're pretty confident it's going to asymptote something around 9 billion. And so this is actually good news. It is going to force cross-border immigration, because there's going to be a lot of countries where everybody's going to be retired and nobody's working. And so it's going to push another social issue in a big way. But this is one of the things where I think Elon Musk has lots of good ideas, but he really thinks we need to rekindle population growth. And I say, no, that is not the solution. we're going to hear a lot more about this in the next week. This legal strategy of school children suing the government for not providing a healthful environment. These are lawsuits that have been filed all over the world, actually. And it turns out that Montana is the very first one that'll actually get to the courtroom next Monday. It'll be live streamed right there. You go to their website to live stream, and I think you're going to see national and very possibly international press in this, because so many of these suits have been filed and they're kicked around in the legal system endlessly, up and down. One of them has been to the Supreme Court twice and sent back down some other court, and Tom tries to explain to me why all this happens, and I'm completely clueless of all these legal mechanics. But this one come Monday is happening. So we have to, as I get to the end here, recognize that this is what the climate models are projecting for the future. And this looks like quite a mess, and it looks like these models are gone crazy from RCP. These are concentration pathways. This is GCM lingo. Of 8.5 that we consider to be basically business as usual with full fossil fuel use, all the way down to 2.6, which is where we really drive fossil fuel emissions to a net zero and can restabilize the climate. And all those lines in between are because the models don't know what humanity's going to decide to do. This is not algorithm error. It's what in the hell is humanity going to decide to do? And that's where we sit right to this day, is with that decision point. It is worth understanding that in the U.S., most of the adult citizenry, the majority of the adult citizenry knows this is real and we better start doing something. So the climate deniers that used to nip at my heels when I'd give public talks are basically gone now. And now the real question is all those things I just showed you about, which of those are going to bubble up and really make it to get the job done. This is a summary of all these things. I don't want to go through this because it's really reiterating what this one leading lab suggests that we need to do, and we can be net zero in emissions by 2050. So a lot of hard thinking says, yes, this is doable. And my last, I first gave this a few months ago and people seem to like it, is, well, what do you want? What can we do now? And I thought, all right, well, I'm going to lob off some things that I find. This one isn't very popular. Drive 65. I drove down from Sydney at 65 and I didn't pass a single car. Not one. And yet it's real. I don't care what you drive. The faster you go, the worse your gas mileage is. I don't care if it's a Tesla even. That's all just aerodynamic resistance. This isn't magic. And so if you care to, I'm just offering suggestions. We've already talked about getting e-bikes, and I should get a commission on e-bike sales. We've talked about wasting less food whenever we can. And now this one, my wife is also going to be mad that I blurted this one out, but I hate clothes dryers. Nobody in Europe has a clothes dryer, and they have a wetter, colder climate than we do. There's no reason we have clothes dryers, and they take big time juice. And now, yeah, don't tell her I said this, though. I actually now steal all my own clothes and spirit them away so she can't put them in the dryer. Less lawn care. Now at the event at lunch today, There are people there at the event that have also targeted. The Americans waste a lot of energy and money on trying to have a lawn like London. And we're not in a London climate with London summer rainfall. It's nuts for us to have lush manicured lawns. Recycling aluminum and cardboard particularly pays off. Plastic is a mess now, we know, but at least these two are ones that are very well established, and we should really, especially aluminum cans. Aluminum takes tons of power to smelt the aluminum, and every aluminum can we should be doing. And then finally, I finally got around to we got going digital on our newspaper, and we resisted for a while because you can see the color of my hair. This generation, geez, we're lame. You know what? Within a week, we said, why didn't we do this a couple of years ago? Yeah, you splurge on a new tablet for $100 and you can read the paper just fine. The hundreds of pounds of newsprint I would take to the recycling center every year, multiplied by everybody, that is a huge amount of unnecessary newsprint. So those are my ideas for free things you can do right now. And I'll end with this. I've always liked this joke. It's been around for a long time. All these things that I'm jumping up and down about. But what if it's a big hoax and we create a better world for nothing? All right, that's it. I'm done.
Well, thank you, Steve. First of all, I want to tell you we want to set some time aside now for questions. We had hoped we would get 30 minutes. I'm not sure. You were a little bit late on that hour. But we'll try and take as much time as we possibly can. We have to get out of here by a certain time. So the other thing I want to say is I have a few things I want to tell you about before you all leave. So please don't leave until I get a chance to do that. So let's go to questions. I want you, each questioner, to come down and talk to this mic. And Chuck, you might check to make sure that mic is in the right place. But so anybody that has a question, I want you to come down here and speak to the mic. Any questions? Any questions?
Oh, probably not. I think I basically solved this one.
Yeah, right. You solved the world's problems, right? In Billings, Montana.
Thank you very much for your presentation. It was very enlightening, and thank you. My question is, when we talk about solar as a renewable energy and as a greener energy source, how do you take into account the manufacturing and the costs and energy inputs into the manufacturing? And if we talk about lithium batteries, we're talking about rare earths. So could you speak to that? Thank you.
Yeah, and that is definitely a topic that has built up a lot, and as it's clear, we're going to lithium batteries. I shouldn't say lithium batteries, because part of what's getting really interesting in the battery world is non-lithium chemistries. And it's way beyond what I can explain to you or even understand myself. But the battery world fully understands that they have a lot of work to do to get away from the rare earth metals, to minimize the amount of these rare earth metals that are used in the batteries. And then the same goes for building solar panels. That the basic, I think it's safe to say that the raw efficiency of conversion efficiency has pretty much stabilized, and now the real challenge is how to minimize those sort of rare earths, and simply the manufacturing efficiency is where really the action's at. And so I can't say they have it nailed, but they don't say they really are trying, because they understand that's quite an issue.
Okay, next. And if you want a question, why don't you go ahead and come down and stand here and wait your turn.
Sure. I'm curious what you have found is most effective to debunk the climate deniers who say the climate's always been changing. What's your best response there, or your most successful one?
Well, the first I can point you to a real good resource, and it's called skepticalscience.org or .com, and it's a bunch of climate scientists that they don't give you a discussion of climate science. They target the denier claims one by one specifically. Like, for example, years ago they said, well, it turns out the sun's just getting brighter. Well, we know darn well the sun isn't getting brighter, and so on Skeptical Science they says, claim, sun is getting brighter, true answer, and they go right at each denier claim one by one. It's by far the best direct material written by climate scientists for whatever claim they cook up next. So that's the first thing and probably the most useful thing I can recommend. You know, the thing I have to say is quite concerning, I know, to all of us, is there's a certain fraction of the populace that is willing to live in just a fact-free world, where there aren't any facts. It's just whatever I feel like is true. And you read about this in the press all the time. And if facts don't matter anymore, then I don't know how I can help. I'm at a loss.
I've got two questions, basically. One of them is, in your research, have you gone back and looked at the geological record for the variables of how the Earth has recovered from events like the...
Yeah, that just isn't my part of the science. There's other paleoclimatologists that look back millions and tens of millions of years, and I just can't study everything, so I really don't...
I was just wondering if you came across with anything.
Yeah, I can't, I can point you to lots of other papers. Lots of other people work on that, but I like to stick to the last 70 years or so and the next 70
Okay,
years.
that's the second question.
Uh-oh.
Use of Landsat and other satellite imagery. Is there a way to determine if there are temperature plumes within the ocean, places where there's more or less
In the ocean?
in the ocean?
Oh yeah, our satellites are measuring sea surface temperature to about 1/10 of a degree accuracy all the time. So that's something that in the last 30 years we've learned a whole bunch about ocean circulation. There's what they call an ocean conveyor belt that circulates water throughout the entire planet in ways that we never used to understand, and now we have a very good handle on that. And that's where all those sextillions of joules of energy are stirring around in the ocean.
Thank you.
Okay.
All right, next.
I was curious, you had talked about the increasing wind speeds of the hurricanes.
Yeah.
What sort of things are we seeing with, like, say, the jet stream? Are we noticing an increase in wind speed there or in other places?
I guess I'll start with the caveat that that isn't exactly my specialty, so I try to keep an eye on it. I'm a terrestrial carbon guy. What they're getting suspicious about is the jet stream might be slowing down and wobbling more. And so we may be getting more of these like extreme winter events, particularly, and maybe that Pacific Northwest summer event, because the jet stream wobbled to lower latitude than it's ever done. And so that is really, in the atmospheric dynamics crowd, that's one of the things they're really trying to see. Is there an actual trend in the jet stream dynamics, or is it just random variability?
It might be more successful if you bring the mic up a little bit closer to your mouth.
thank you for going through all of the different power generation sources.
Yeah.
But one that I noticed you did not mention, and it may not be an expertise of yours, but I recently read an article that there's a lot of hope for geothermal, particularly in areas like Montana and Wyoming, where we have got hot, undersoil conditions.
Yeah.
And like Mexico City just had a big volcano go off in Hawaii.
Yep.
And there are a lot of places like
Yeah.
that where there's a lot of heat.
You know, I had a geothermal slide that I used yesterday, and I just forgot it. So let me give a summary of what appears, and this could get pretty darn interesting. All these oil wells that have been dug, there's millions of them, if they can go and figure out the ones that have a geothermal resource close to the surface, they can return to that oil well that's already been dug, expand it, and then be pumping the superheated water to the surface. And this is not just an idle pipe dream. There's a couple of companies prototyping this right now, I think in Utah. And so I'm glad you reminded me. That's one to watch also. And think of all the oil wells and all the oil well workers that could really help out on that if it starts panning out.
Thank you.
Okay, next.
I'm wondering if you have a suggestion. I'm pretty frugal, and sometimes I get up at night and see all these little teeny lights. I hardly have to turn anything on because our stove has a light. The power strips have lights.
Yep.
Is there any way to be not using all that electricity during the nighttime? Or
Well, you know, the good news, and we should at least celebrate our victories, LED lighting has been a massive step change from our old incandescent lights. They are 10 times more efficient than our old-time light bulbs. Having said that, you're sure right that every gizmo you plug in has a little LED going for power or for the time, and they individually aren't very much, but there's probably dozens of them in every house. And this is something where most of those lights are just a convenience. They're not really necessary. And it'd be an interesting challenge to the electronics industry to say, you know what, isn't there a way that we just do less of those? Because they're on all the time. So even though they're not much, the time adds up.
Further questions? Further questions? My goodness, this is a quiet group. Where are we? Well, if there are no further questions,
No further questions.
we will conclude, and thank you very much.
Okay.
So I want to point out to you that this is only one program in a whole week of programs, and Steve is going to be with us and has been with us on a whole bunch of different programs. He already was at the